Welcome to Virtual Local Area Networks, or VLANs. This presentation is designed to introduce the topics of VLANs and VLAN trunks and give an example of how the technology is applied in a networking situation. Proper implementation of VLAN technology leads to broadcast containment, network organization, and a level of network security. A VLAN allows a network administrator to create logical groups of network devices that act as if they are on their own independent network, even if they share a common infrastructure with other VLANs. What does this mean? It means that a networker can logically configure a single physical switch to act as if it is multiple and separate logical switches. Moreover, multiple switches that are configured with similar VLANs can be interconnected, and devices on the same VLAN can communicate with each other across those switches. A simple VLAN implementation is displayed in this diagram. There are two groups of users in this graphic, faculty and student. Notice that when all PCs are under the same IP network and PC 1 sends a broadcast, all devices receive and must process that broadcast. One benefit of VLAN implementation is broadcast containment. Each VLAN is its own broadcast domain. After VLAN implementation, broadcasts sent by PC 1, which is now on VLAN 10, only reach other devices that are on VLAN 10. No longer do devices on the student or any other VLAN receive or process broadcasts from the faculty VLAN. Broadcast containment is beneficial because it reduces unnecessary network bandwidth usage due to broadcasts. As a result, the amount of CPU cycles devices use to process the broadcasts is also reduced. When VLANs are implemented, each VLAN must be on a different IP subnet than other VLANs. Because of this, a Layer 3 device such as a router is needed to enable communication between VLANs. This inter-VLAN routing is beyond the scope of this presentation. Another benefit of VLANs is network organization. Think about a school, for example. It makes sense for there to be 3 VLANs, a student VLAN, a faculty VLAN, and perhaps a guest VLAN for visitors that may need internet access. This is shown here. Notice that each VLAN has its own subnet address. Another example of a VLAN implementation might be an enterprise headquarters building. In such a building, there may be many departments such as research and development, management, shipping and receiving, accounting, advertising, and human resources. Assigning each department to its own VLAN leads not only to broadcast containment, but also better network organization. Because different VLANs require different IP subnet addresses, a layer of security is also provided by VLAN implementation. In our example of a school, the student VLAN is separate from the faculty and guest VLANs. This logical separation reduces the probability of confidential information such as grades, student information, and other administrative information from being compromised. Access control lists can be used to further enhance security across VLANs. Now that you know some benefits of VLAN implementation, let's look at the most popular type of VLAN configuration, static port-based VLAN assignment. Static VLAN assignment requires an administrator to manually assign each port on a switch to a specific VLAN. As you can see here, specific ports have been assigned to specific VLANs. Generally, the administrator will create the VLAN first and then assign the ports to the appropriate VLAN. The device that is plugged into the port automatically becomes part of that VLAN. If someone in an organization moves from an office on one floor to a different floor, a simple port configuration enables that person to continue to participate in the appropriate VLAN. VLAN switches are often connected by using a crossover cable. These switch interconnections are called trunks. Trunks carry traffic from all VLANs on a single cable. Without trunks, each VLAN on a switch would need its own cable to connect to its matching VLAN on another switch. Trunk ports solve this problem by tagging frames with specific VLAN information. The most used tagging protocol is IEEE 802.1q. In this animation, when switch 2 receives the frames, it tags them with the VLAN information from which they originated, 10 and 30. After traversing the trunk lines and arriving at switch 3, the tags are stripped and the frames are sent out the appropriate ports to arrive at the correct end device. This concludes our video on the benefits and operation of VLANs. Implementation of VLANs is extremely important and common in large LAN environments. Although the information in this presentation is important, it is only introductory. For more information on VLANs, go to www.cisco.com and search for inter-VLAN routing, VLAN configuration, and VLAN trunking protocol.